Hi everyone, my name is Shego. I am super excited starting this course with you. I'm the lead instructor here at ASO Innovation, and this program is meant to train computer vision from beginner level to an advanced level, where we actually guide you with different projects, step by step projects at every phase of learning. You understand what you are doing practically and by concept. So without further ado, let's dive straight into the business. So here are the phases of the learning. Firstly, we have the fundamentals phase, which we actually where we introduce the concepts of computer vision. We guide you on what computer vision is step by step. And if you are actually an expert or you're not a beginner, you are someone that is actually aware of what computer vision is, you know what computer vision is, you can just skip this fundamental phase because we are just talking about what is computer vision, the need for computer vision, and other things related to computer visions that are very essential, like a real world application. So in the second phase of this learning, we look at future extractions. Here we dive deep into the basic um, edge detection techniques. We look at corner points or interest area detection and feature descriptors. So these are one of the basic, like, okay, intro to computer vision. Next, we move straight into deep learning for computer vision, where we actually like explore models on, let me say, neural network like CNN, which is a convolutional neural networks, which could help in image classification, and GAN, which would play games actually in any way. You will play game along learning this program as well at this particular phase. So then phase four of this project or learning, you would actually look into image processing, where you explore image transformation, image enhancement, noise reductions, and the likes. Then you do image classification. There are different type of image classification. We have multi-class classification. We have zero shot classification. We have multi-label classification. You actually explore this image classification. Then we do image dictations. So we dictate image in basics. We do the rest of image detection in object dictation, but before then we dictate image in segmentation. So I wrote dictation instead of image segmentation, still in place because inside the images you're actually dictating images, you're trying to dictate objects. So in image segmentation we look at semantic segmentation, instance segmentation, and panoptic segmentation. Have you ever wonder, um, having a scene where you have a lot of people in the picture, or let me say in a particular scene, and you want to like tell, okay, this is this category of objects, or let me say in this category of the image, there are people, these are cats, these are dog, and the like. So image segmentation will actually help you in actually classifying them, like segmenting them to their category. Firstly, image segmentation, image semantics would help you like make meanings of, okay, this is human being, this is dog, this is cat. But instant segmentation on the other hand, now like look at the image you're having. This is cat one, this is cat two, this is cat three, this is cat four. You understand? That's what it does. While panoptics, it's a combination of both semantic and instance segmentation that is actually hold the image. Okay, oh, this is a person and this is person one. This is a dog and this is a dog two or dog one. Example, something like that. You understand? So finally, we dive into object tracking and object detection, where we actually like explore more of object detection. We use different models, use YOLO, SSNet, or even use some two ways detectors like max RNN, fast RNN, fast pass RNN. We use models like ResNet and the likes. But the most important thing along this phase is that we will actually be solving problem, be doing projects at every phase except for the fundamental stage. Without further ado, let's start with the fundamental phase. In this section, we look at what is computer vision, the need for computer vision, human vision versus computer vision, and finally, the real world application of computer vision. What is computer vision? Computer vision is actually a branch of artificial intelligence that enable machine to interpret and understand visual information from the world. It allows us to actually like take data, take visual information, take visual data, make an informed decision on them. Take for instance, you're having a company where you have a CCTV camera that record every activity that is going on a daily basis. From there, you could actually learn to make informed decision on probably if you actually like automate some things, check repetitive tasks, naturally reducing costs, and it helps you make an informed decision in general in based on the data it has actually gotten. So compared to relying on our normal human eyes that we actually like have to like view a lot of datas, process over and over and over and over again. Um, Computer vision actually helps us in making it much faster, and as such in due to this, there's actually a need for us to actually look at the need for computer vision. So what is the need for computer vision? The need for computer vision stems from we having billions of data being generated every seconds. I mean, every seconds of the day, every seconds in our 24 hours we're having in a day, we're having billions of data being generated from our smartphone to our cameras to our from our sensors, which our normal human eyes cannot process, as I've said earlier. And the need for a more faster machine, a more efficient means for actually like looking at this data, processing them and making an informed decision is more paramount and important. So the need for computer vision becomes more essential as it allow machine to like automatically analyze, interpret, and even take action upon the visual data it sees. So we don't have to do anything than just relying on the results from the machine. For enhancing safety in self-driving cars, to actually improving efficiency in medical diagnosis, computer vision has actually like serve as a bridge between the raw information and our meaningful insight, which is actually like enabling a more smarter decision and fast innovation. Next, we look at the difference between this computer vision and human vision. So let's begin with human vision. Human vision is literally our eyes seeing something. We will be able to like make prediction. Oh, this is a dog. We've captured it. It's sent a signal is sent to our brain. After a signal is sent to our brain, our brain processes it and tells us, oh, this is a pen, this is a dog, this is a cat, this is a car, this is an house. Computer vision, on the other hand, uses similar principle, but instead of using a human eyes, it uses camera to actually capture the raw image, capture the raw activities happening, while we have some algorithm behind the scenes serving as our brain that actually help us in actually analyzing these pixels and making pattern to extract meanings. You understand? So after analyzing this data, we will be able to arrive at a smarter and a meaningful uh, decisions at the end of the day. The importance of this computer vision and over human vision is that computer vision can process a lot of data between a split seconds. Next, would look at the application of computer vision. Where are computer vision even applicable? I bet it with you, computer vision is applicable everywhere. Coming from healthcare, where you can actually be the machine learning medical way assistant, um, to agriculture, where you can actually build a simple system that does a disease detection system in plant, in transport, where you can do traffic control, traffic violation system with computer vision, in real estate, where you can actually like um, build system that are fascinating that could actually help us make decisions that uh, increases the business return on income, return on investment, straight to education, where we could build systems that helps in actually reducing cheating and improving student performance. Example of system like that is is examination cheating dictation system, where the system will dictate the crime being committed in an exam hall, the type of cheating the student commits in an exam hall. Afterwards, it sends the signals into the database. The supervisor invigilator sees it, record it, and penalize the student. In as such, student will actually be compelled to read more and more, and a lot more. So I doubt if there's any section that that computer vision is not being used. So now we've actually got into the end of the fundamentals. Next, we are diving straight into the future instructions. Thank you. So, future instruction. What is future instructions are part of the objective we are looking in today? We look at object detection techniques. We look at our corner and interest point detection. We look at feature descriptors. We look at practical application of feature instructions, where we would also code, write code, and at each section from edge detection techniques, corner and interest point detection, feature descriptors, to practical application, we'll keep giving you codes, write codes that actually depicts each segment, each sections. Thank you.